So let's start with size of operator. Fine. Size of operator is another very important unary operator. Fine. We just need to know how this functions. We'll be using it in a number of things in the coming lecture, right? So it's a unary operator. What does it do is, it just gives you how the syntax works is, you use the keyword size of. It is an operator. You use the keyword size of, and in parentheses, you here may pass any data type. Only two things you can pass: any variable name or any data type. Fine. In these parentheses, you can pass any data type, keyword, whatever various data types we have, their keywords, or any variable name. If you have made any variable of any data type, you can pass that variable name here. Those two kind of things you may pass into the parentheses of this size of operator. Right? And how this will work is, as parameters, and will compute the size of that variable or the size of that data type in bytes. We all understand what is a byte? So we'll compute that. If you are passing a variable name, it will compute what is the size of that variable. Fine. And it will return you how many bytes, the size of that variable in how many bytes it is. It will return you that count of bytes it will return that actually to you, and you may assign that to some another integer variable. Is that okay? Okay. See, like look here, the simple program. Look here, a very simple program. There. What we are here doing is, yet you are not, we haven't read about arrays, but for now, just assume ki A is a different data type that we'll be starting today, which we call as array. And the size of variable A is 10 bytes. I'm telling you for now, just assume it. How it come up 10, we'll learn in coming lecture. Then int I, you created a variable I, and integer type variable hai, so what would be its size? Its size will be 2 bytes. Is that okay to everyone? Fine. Okay. Now, this line will be executed. This says printf \n size of I. This will be printed just like that. On the output screen, it will just print you size of I equal to, what is the size? This. This is an operator. We are passing a variable I into it, which is a variable name. It will compute the size of this variable, and the size of variable is always defined by the size of the data type it is from. So it is of integer data type, so it is 2 bytes. So it will return 2 and print here 2. Fine. Then next line, this will be executed. It will again print, okay, A size of variable A is equal to, again we are using this operator in which we are passing an array name actually. This is another type of variable. We'll learn in coming lecture. A, and it will print a size of, this is in 10 bytes, so it will return 10 and print 10 here on the output screen. Then next, printf size of int, it will print here size of int fine, and it will print size of int. Again, int you passed here in this case a data type, a keyword which is representing a data type, integer data type. So it will compute for this data type the size and return the size for integer data type is 2 for the 16-bit compiler, which we are discussing in this course. Fine? Is that okay to everyone? So that is how the output for this program would be, and that is how the size of operator works. So it's a very simple operator. It's a unary operator in which you may pass two types of parameters, a variable name or a data type. Right? Whatever, if you are passing a variable name, it will compute what data type variable it is and what is the size for that variable is allotted in the memory in number of bytes and return you that count. Fine. And that count you may assign to some another integer because it will definitely return an integer only. Size will be always a integer number of bytes, so it will return you that, and you can pass that value to an integer variable, or you can just, like here we are printing that value. Simple. That's simple. Okay. Now next start the pointer arithmetics. That's very, very important topic. Let's focus on pointer arithmetics. We all understand how we create a pointer, how we declare a pointer, that we have already studied in asterisk P. So this will create P to be a pointer, right? So what will happen in memory is some 2 bytes of space is allocated for variable P, right? And whatever, how we assign value of P to be P equal to address of I. Say I was initially defined data type. So for I, whatever, this is just a repetition of what we already know, right? So whatever variable I was there, the base address of I, if was 200, by this line of code, address of operator will fetch the address of this variable and pass it to pointer P. So it is 200 at this place. Suppose the base address is 400. Is that okay? That much we know. Fine. Now we are saying, fine, if we make integer variables, like say, if I make int I equal to 5, comma, j equal to 10, comma, k, semicolon. This is like declaring 3 variables I, j and k. Fine, 5. And in I, we are also initializing variable I with value 5. We are also initializing variable j with value 10. And we are creating another variable k in which we are not assigning any value like that. Right? So if I do, sorry, not this one. Okay, if I do k equal to I, what operation I'm performing? I'm just assigning value of I to k. Fine. Fine. This is just nothing. Assignment operator I am using. This is the assignment operator. You all understand that? Fine. Okay. As assignment operator, use of assignment operator is allowed for your normal variables of any data type, integer, character, float. Same way, use of assignment operator is allowed in case of pointers. Like here, if you create 2 pointers, P1 and P2, you may initialize them, you will always initialize them with some variable address, right? But you may use assignment operator like here, P1 pointer is equal to P2 pointer. What that will do, whatever the address in P2 pointer is there, that same will be copied to P1 pointer. Fine. Like now both these pointers P1 and P2 will be pointing to same address. Fine. Or we can say both of them will be storing the same memory address. Fine. Okay. Now let's look here. Let's come back to normal variables. If I write I plus plus, we all understand this is a post increment operator. Fine. It is allowed. What this will do? It will increment the value of I from 5 to 6. Fine. After the execution of this line of code, value of I would be 6. Fine. That's simple. Okay. Similarly, Similarly, same increment, you may talk about pre-increment or post-increment, pre-decrement or post-decrement. Same way, the increment decrement operators, sorry, increment and decrement operators on a pointer are allowed. Once you create pointers, you may use pre-increment, post-increment on them. You may use post-decrement and pre-decrement on them. Fine. But how they will function, that's important. How they will function. We'll just understand that more in detail with one example. But for now, just introductory part, that what operations you can perform on pointers. Fine. Third, let's come back here. If we have this I and j, two variables, and if I write k equal to I plus 5, semicolon. Look at this. K is equal to I plus 5, semicolon. Is that a valid operation? It is. We are doing just a simple arithmetic instruction, writing our arithmetic instruction. On the right hand side to assignment operator, we have a variable and an integer constant. We are adding these two values. It will just fetch the value of I, say 5, and add value 5 to it and assign that to k. So now after the execution of this line of code, the value in k would be 10. Is that simple? Fine. Similarly, for pointers, you may add or delete an integer constant. This is allowed. Like here, we created two integer pointers, p1 and p2. Fine. Here you will be initializing them to some address, definitely. Fine. But this kind of operation is allowed. That if you do p2 is equal to p1 plus 5, where this is a integer operator, is integer constant. So that kind of operations are allowed on pointers. Okay. But again, same thing, if I ask you here, can I write, let's say if I would have created here another pointer, say p3 of same data type, then if I write p3 equal to p1 plus p2, semicolon. The question is this a valid arithmetic instruction in case of pointer arithmetics? The answer to this is no. It is not a valid arithmetic instruction because pointers arithmetic allow you to add an integer constant to a pointer. Like here, you can add an integer constant to a pointer, but you cannot add two pointers. It's not allowed. Fine. Okay. Similarly, okay, subtraction of two pointers. It is allowed. Addition of two pointers is not allowed. Subtraction of two pointers is allowed. But that has a specific case. That is allowed only if these two pointers are pointing to same array. We'll discuss array just after a few slides, and then we will come back to this discussion. Okay? Then we'll come back to this point discussion. Till now, you just be clear with these things. In pointer arithmetic, you can use assignment operator. You can assign one pointer equal to another pointer. You can use increment decrement operators. That given a pointer, you may use increment operator, decrement operator, pre-increment, pre-decrement, post-increment, post-decrement operators on a pointer. Fine. Another interesting part is this one, that it allows you to add or subtract a integer constant to a pointer.
Excuse me, ma'am.
Yes, dear.
Ma'am, actually our CR is still outside. Could you please allow him to enter?
Okay, I'll do. Okay, is that okay, everyone? Fine. So these three operations are allowed. This subtraction of two pointers is also allowed, but in a specific case. Fine? Fine? Just let me give a second. Okay. Is that okay? We'll come back to this later, and now let's understand in detail how this will actually be executing, what changes it will be making. Okay, let's go to this slide. Okay, before that, a little introductory, another part. What operations are not allowed? What is not allowed is you cannot multiply or divide a given. You cannot multiply or divide. Just give me a second. You cannot multiply or divide a given integer constant to a pointer. That means we cannot allow p1 multiply 2. It's not allowed. Or if I write p1 multiply p2, if I write p1 divided by 2, none of these operations is allowed. That means basically multiplication and subtraction of a pointer with an integer constant, or multiplication and subtraction of two pointers is not allowed. Fine? We clear with this part? These operations are allowed and these are not allowed in pointer arithmetic. Now we'll understand how actually they work. Let's understand how actually they work. Fine? Now look at the first example, that increment or decrement of a pointer. How increment or decrement of a pointer actually works. Fine? Let's see, you assume this line of code, whatever code I'm writing now, just assume that that is written in void main. In the body of main function, all these lines of code are written, and then accordingly we'll discuss how the execution is going on. Fine? Look at this line of code now. With the first line of code, what will happen in memory, again 2 bytes of space is allocated for variable a, because it is an integer type variable, we all know, so it will be 2 bytes. And we also initialized variable a, so it is initialized with value 5. Right? Next instruction is, we are creating a pointer of integer data type as well as assigning the address of a to that pointer. So that is the syntax we have already discussed. So what this will do is, you will create, in memory, it will create a pointer p, another 2 bytes of space for pointer p. Fine? And address of a is assigned to it. So let's suppose the address of a was 200. So 200 will be saved as a value for p. And let's suppose address for p is 400. Simple. As much we already know, doing easily. Now, look here. What do you think what would be the output? Just write down on the chat box. What would be the output? Just give it a thought quickly. What would be the output here? What would be the output printed here? What would be the output printed here? Write down these 3 lines quickly, and then I'll write down and you will see what is your answer, right or wrong. Let me see. Sorry. Oh my God. I have to write it again. Quickly write down your answer by the time accidentally I did. Fine. Output for this will be, let me see if somebody has tried writing output. Size of I, size of a is 10, size of int only. The answer will be size. 200, 500, 520 first line. It means here this actually it is not this slash, it is backslash t. I was just trying to put a tab into it. It is backslash t. Okay. Now let's discuss this. It is a backslash t, and that's a tab. How tab works. Fine. Now look at here. Once we'll be executing this line of code, the output will be 5, 200. A is 5 and 200. Fine. That will be the output. I hope this is same from the previous pointer class. So you must be agreeing with this answer. Fine. Now next line of code executed is increment, post increment A. So what this will do after the execution of this line of code, this will become 6. This value will be incremented and it will become 6. Fine. When this line will be executed, again it will print all these values. Asterisk P is dereferencing the value of P. Dereferencing is fetching the value at the address stored in P. So at the address stored in P is 200 and the 200 address value is 6. So it will print 6. It will print P itself. So P is 200. Again it will print value of A. Value of A is 6. Value address of A. Address of A is 200. Up to here, I guess everybody, no one should be having any query, right? And we all understand why %u and why %d here. Because wherever we are trying to print address, so address is like a unsigned integer. So we are using format specifier as %u. And whenever we are trying to print an integer, then we are using format specifier to be %u. Because integers, we also have negative integers. Fine. Okay. Now, next line of code to be executed is say this one. Post increment P. Right? Where P is a pointer, and we said this is allowed in pointer arithmetic. So what will happen with this line of code is now this 200 will become 202. Not 201. It will become 202. Fine. Just I'll get back to you on this. Once let me print the output to this. It will print dereference this. So it will fetch value at 202. That is the next 2 byte space. Whatever the value would have been here. Some garbage value actually. So whatever has been in these 2 bytes of space, that because that is the address 202. It will fetch whatever was here. That is basically a garbage value. Let's assume that was 50 or something. So it will print that garbage value. Basically, it is a garbage value at address 202. It is a garbage value at address 202. Fine. And then it will print P. P is what P is storing. P is storing 202. So it will definitely print 202. Then it will print value of A. Value of A is 6. Address of A. Address of A is 200. Fine. Fine. Now just the query must be coming to you is why this 2 after the increment. After this increment value, why this value in P turned out to be 202 and not 201? Why so? Why so? Okay. For this, try to understand the concept. Try to understand the concept. What basically pointer is? Basically, pointer is a special type of variable that will just store address of some type of, if pointer is of integer type, so it will store address of integer type variable. If it is a pointer of character type, it will store address of a character type variable. That is how it is doing. Simple. Fine. Now, whenever we increment the integer pointer, we logically want to do is, we want this pointer to point to next integer value. Fine. We want this pointer to point to next integer value. So in case of like whenever you are incrementing a pointer, if it is a pointer of integer type, integer takes size of 2 bytes, so the address will change by 2 bytes. If you are incrementing a character type pointer, then character variable takes 1 byte of space. In that case, this address will change by 1 byte. Fine. If you are incrementing a float type pointer, then the address in that pointer will change by 4 bytes. If it is a pointer of float data type and it was storing the base address as 200 and we increment it, then it will store value 204. Fine. Fine. I'm basically trying to say you is, whenever we are incrementing a pointer, conceptually we want the logic to be that pointer should, if it is an integer pointer, now it was stored here, we want in these 2 bytes. Now we want this, it was pointing here. When we are incrementing it, we want it to point to next integer. So next 2 bytes it will jump. But if it is a float type pointer, so it was addressing these 4 bytes of space, pointing to these 4 bytes of space. On incrementing, we want it to point to next float value. So it will jump by 4 bytes. That is how logically it do. And that is how this increment is important to understand. It totally depends.
Excuse me, ma'am.
Value will be increased by 1 or increased by 2 or increased by 4. It will totally depend what data type of variable it is. Fine?
Excuse me, ma'am.
Just give me a second here. I'll take your queries. Just give me a second. Is that okay? Or you can this is one way of understanding it. Or you can understand it like a formulation. P, value in P will be equal to value in P plus size of its data type. Whatever data type of that, generic I am trying to explain, whatever the data type of that pointer is, you can formulate this logic to be like this. On incrementing P, on incrementing pre or post, on incrementing P, the new value in P will be P equal to P, whatever the past value in that was, plus size of the data type of this pointer. Like in this particular case, we talk about the initial value in P was 200, plus we'll compute size of the data type of P is int, integer type. So it will compute size of int. Int ka size kya hai? Is 2 bytes because it is, we are talking about 16-bit compiler in which size of integer is 2 bytes. So size of int will return you 2 bytes. So it will add 2. And so the new value in P after this will be 202. Fine. Just take one more example. Just give me 1 second. Suppose if we are creating a float value, float pointer, let's say float FP, float pointer. Fine. And we are creating a float variable, float, let's say F equal to 5.1. That's our variable. And we want FP to store address of F. Fine. Fine. Up to this point of time, if we print all these things, we understand. Is that simple? But if we do, after this line of code, if we do FP in post increment, the value of FP. Fine. Fine. So suppose the address of F was 400. After this line of code, so value in FP was 400. Fine. After this line of code, the value in FP will be 404. Just put it in this formula. Just note down this formula. Is that okay? Now, any query on this part?
Excuse me, ma'am.
Yes.
Ma'am, you took the case of post increment. What if we are take the case of pre increment?
Same thing there. Value of P will change in the same way. It is just when you will be using these post increment and see pre-increment and post increment. For that variable, they are acting in the same way. But if you are putting it in an expression, then if you are using pre-increment, that value is incremented first and then used for the next operation in that expression. But if we are using post increment, the initial value of that variable is taken for that expression and that value is incremented later in P, later in that variable. So same, logic is same. Here I am keeping it simple so that you understand what we are trying to do. Yeah, right now I'm not putting it in any expression. Is that okay?
Yeah, okay.
Everyone good with this? Everyone good with this? Just you need to pay attention here. This is the key thing, that what logically we want to do is whenever we are incrementing a pointer, we logically want it to point to next variable of the same data type. And how that will do so? By jumping the size of that variable. Conceptually, try to understand it. By jumping the size of that variable. Fine? So whenever we are incrementing our integer pointer, so exactly in numeric terms, the value of that value in pointer will change by 2. When you are incrementing a float pointer, that value will change by 4. When you are incrementing a character pointer, the value in that pointer will change by 1. Right? Or you can just simply formalize it this way. Try to understand the concept this way. Right? This example is clear to everyone? Can we go to next example?
Yes, ma'am.
Okay. Same way decrement will work. Okay. Same way, if I put here minus minus, so instead of this plus, it would be minus. It will decrement value by 2 for integer pointer. It will for character pointer value will be decremented by 1. For float pointer value will be decremented by 4. That is how it will work. Right? So let's do here. That's another interesting operation. What does this interesting operation says is, let me just, addition and subtraction of an integer constant is allowed to a pointer. We saw in the last slide a simple example. Let's do with, again I'm assuming whatever the code is written here is written in the body of main function. Fine. So first line, once this will be executed, we all know this. I hope we are perfect by this time in this. It will create 2 bytes of space for variable a and assign value 5 to this. And we are again assuming that the base address is 200. Precisely, these 2 bytes are 200 and 201, as we know. Right? Now, when this line of code will be executed, another 2 bytes of space is created for pointer p, and that will store the address of variable a. That is how it is doing. Simple? Simple? Fine. Now, once this line of code will be executed, you think, write down your piece of paper and pen, your answer, and then verify your answer with my answer. Okay? First write down, think what will be the output of this line, and then verify your answer with my answer. Okay? It's very much same. Fine? We all agree with this? Now, next line of code, pay attention here. It is dereferencing P. It is dereferencing P. It is not a pointer arithmetic expression. It is just a simple arithmetic expression using pointers. Okay, for now you just can avoid that detail. It is how this expression will be evaluated. See, first, of course, for assignment operator, it has lowest precedence. So as well as it is right to left associated. First higher precedence is of the highest. आप precedence table देखोगे, highest precedence is of dereferencing operator. So first this will be done. Dereferencing means it will replace this value, dereference the value at P, it will fetch the value at address 200, which is value 5. So that is 5 here. Fine. So 5, then addition operation will be performed, because after dereference operator, the second comes in precedence of these three operators is addition operator. Then addition will be done. So 5 plus 5. This will be done. So it evaluating it to be 10. Then assignment operator will be executed. Assignment operator says, okay, assign this 10 value. Where to assign this 10 value? To this dereferenced value. So assign this 10 value here. Fine. Fine. After this line of code, 10 value will be assigned here. So actually value of A is changed in this manner. We all okay with this? Fine. And once now, if you print this, it will print dereference P, that means 200 address P, whatever value is there, fetch that value, and that value is 10. Print P, P is value 200. Fine. Print A, value of A is 10. Print address of A. Address of A is, as we discussed, we print only the base address, that is 200. So that will be the output for this line of code. Simple, eh? Any query? No? Okay, good. Let's move next. Look here. Now execute this line of code. Now execute this line of code with the same previous assumptions, that address of A is 200, address of P is 400, rest is same. Execute this quickly. You have 1 minute to go quickly through this. Done? Now verify your answer with mine. Dereferencing, E 200. Value of A will be again 5. Address of A will be 200. Okay. It is actually 0. Don't get confused. Okay. Now, once this is done, P is equal to P plus 5. What this will do is, see here, some garbage value will be printed. Some garbage value. At address. Address is memory address. We all understand that, right? At address 210. This will be the first thing printed. Then P will be printing is 210. Then A will be printed as 5. Address of A is 200. That will be the output for this line of code. Fine. Okay, let me just, I hope this, there's no issue, right? Let's discuss this one. As we discussed how the increment works, we formulated increment as P is equal to value of in P, initial value of P, plus size of its data type of this pointer. Now, when we are adding an integer value to that, the formula changes, like the size of the data type of pointer multiply with that integer constant 5, like in this case it is 5, multiply with that integer constant. That major change comes here. Multiply with 5, the integer constant you are adding to it. That is a major change comes in here. Fine. What this is doing? Logically, first let's talk about logically. Logically, with this line of code, what we want to do is, like if P is pointing to this pointer, sorry, this integer value. If I'm adding 5 to this pointer, I want it to jump to 5 next pointers value, sorry, 5 next integer variables and point to fifth pointer from this. Fine? Point to fifth pointer from this. First, second, third, fourth, fifth, sixth. If I'm adding 5, to jump 5 pointers place and point to sixth integer variable. That I want this pointer to do. If I'm adding 5 to it. If I'm adding just 1 to it, it was like it was pointing initially to these 2 bytes of one integer value. I want it to point to next integer value. When I'm adding 2 to it, I want it to jump 1, 2, 3, 4. 4 bytes and point next to it. So if I'm adding 5, so I want it to jump to 5 integer, size of 5 integer variables and then point to next address. Or you can formulate the same logic like this one. P is equal to P plus size of its data type into 5. Fine. Like after this line of code, initially P was just pointing to address 200. After the execution of this line of code, P will point to address 210. That is, after adding 10 bytes of space to it, it will now pointing to these 2 bytes of space. Fine. Is this clear to everyone? Is this clear to everyone? Fine. This formulation is clear. So once you be printed these values, dereferencing P, it will print whatever the garbage value in this case at address 210 is. Value in P is 210. A is 5. Address of A is 200. Fine. Fine. Conceptually, समझ आया what we are trying to do? We are just trying to play. If we are incrementing one, we want that pointer to point to next integer. We want that pointer to point to next float, if float value, if it is a float pointer. So on and so forth. Fine. Fine. Simple, eh? Let's go next. Now you will tell me output to this one. Tell me output to this one. Assuming the same thing, that A variable is at address 200. P is at address 400. Let's say P1 is at address 600 in memory. You have a little hint. Now tell me the output. Up to this line of execution I have executed. verify your answer. Any query? Let me know. Any query? 5 250. Good. Garbage value 210. Yes. No, ma'am. Lakshay, Kushik, and Rishant. Okay. Dear, what you didn't get actually? I believe this is very much same as the last one. See, I'm just quickly going through this part. Creating a variable. Here we created a variable. 2 bytes space allocated, assigned value 5 to it. Simple. With this line of code, creating a pointer P, assigning the address of variable A to it. So assign 200 to this value. Fine. Creating another pointer. Fine. So up to this line of code, just the pointer is created. Here must have been initially some garbage value. Fine. With next line of code, P1 is equal to P. The very first arithmetic operation allowed in pointers is assignment operator. You can assign one pointer equal to 2. In that case, both pointers will be saving the same address. So this is what we have done here, that P1 is equal to P. So P1 will store address 200, which was in P. Simple, same address. Right? Now, printf these values, dereference P. That means value at address stored in P, which is 200. So 200, whatever the value at address 200, it is 5. So it is printed 5. Print value at P. So it will print 200, 200 printed. Print value at A, it will print value at A, which is 5, right? Address of variable A, printed, printed, printed. I think up to here, no problem. Fine, simple. Now, look here. P1 is equal to P plus 5. Fine. This arithmetic operation is allowed, as we are saying that we allow to add an integer constant to a pointer. Fine. So this part, adding an integer constant to a pointer is allowed. And assigning a pointer value to another pointer is allowed. Fine. So this is allowed. Simple. Simple. Because, see, whenever you get into some expressions, try to understand one important thing. Always, usually, what operations are allowed or not allowed, it depends on what you are playing with. Fine. If on the right hand side of an assignment operator, if you have, say, float variables, fine, and on the left hand side of the assignment operator, you have a character variable. So this operation is not allowed, because how you will assign a float value to a character, right? But if in case on the right hand side of an assignment operator, you have a number of variables, a number of constants, and all those are integer variables and integer constants, and on the left hand side you have a variable which is of integer data type, then this operation is allowed. Fine, because you can assign an integer to an integer. Fine, but you cannot assign a float value to a character. Right? Because they are like of different data types. They are belonging to different classes. Fine. Now, next we come here, looking at this expression. Fine. We are saying on the right hand side we have a pointer and adding a constant to it. Fine. When we are adding a pointer to a constant, basically pointer is storing a memory address. We are adding a constant to it, and that is also changing the memory address in certain ways. It's like jumping that address to a certain number of jumps, whatever the integer constant is. So that is again an integer constant, address. And on the left hand side also you have a pointer, not a dereferenced pointer. Pay attention here, not a dereferenced pointer. If I would have written here asterisk sign, then this is not a valid operation. But if it is not a asterisk sign here, only P1 is equal to P2, only P1 is equal to P plus 5. So this expression is resulting in an address. Fine? Address at value P plus 5 added to it. So like 5 jumps in that address. Right? So it is 210. Are you okay with this? How it is 210? Same as the previous explanation. P is storing a particular address that is 200 and you are adding 5 to it. It will be size of int into 5. Size of int is 2 into 5, 10. So it will be 210. Fine. So this value will evaluate to be 210. Fine. Fine. Now we are assigning this 210 to P1. Fine. But 210 has a specific property that this 210 is an address, memory address. And here it must be a pointer. You can assign this memory address only to a pointer. So it is fine. As you can assign an integer expression equal to an integer variable. Same way, you can assign this address expression, memory address expression, and assign a memory address to a pointer. So this expression is fine. What you are doing with this is assigning P1 to hold a new address, which is 210. Clear? Now, just pay attention. If I would have written this line expression as P1 equal to P plus 5, then compiler would have shown an error here. It would have shown error that L value is not L value and right L value R value error. What that error is, because this right hand side is a address, is evaluating to a value which is a memory address. However, left hand side is dereferencing P1, so that means it is an integer value. You cannot assign integer value equate integer value equal to a address. But if I just write only asterisk P, sorry, not asterisk, only P, then it is not an integer. It is storing again a memory address because it is a pointer. So it has a specific type that it will be storing a address. Fine. So address is equal to address that you can do. Then it will be no error. Fine. Fine. I guess this would have been your confusion. If this is clear now, then there is like no issue at this point of explaining these lines. Fine. Any query? Any query?
No, ma'am, we get it. It's pretty good.
Good, everyone? Sorry, this is very important. This is very, very important actually. We'll be playing with this a lot. Fine. So let's move next. Okay, this is basically I wrote to ask you to, okay, let me write an example.
Excuse me, ma'am.
Yes, dear.
Ma'am, I have an FEC class 4 to 6.
Actually, I wanted to continue. How many of you, how many of students have FEC class?